Does refraction actually happen the way that we are told? We are told that light bends down and that raises the image up, and the light bends down as it enters a denser medium, raising the image up, making things appear higher. Now, I don't believe that's true, and I believe I can prove that, so let's take a look.
You agree?
Yeah.
Right.
Yes.
So all we've got to do is change the refractive index. And he does that by pouring, I think, liquid butane on it, which has a temperature of about 0 degrees Celsius. So it drastically alters the refractive index. And as soon as he does that... Oh, bugger, I skipped when I shouldn't have. Go back. We'll do it again. As soon as he pours it on... As soon as he pours it on... Come on, make me look silly. Here we go. As soon as he pours it on, it changes the refractive index. And you can see...
So look how much of the blue you can see here, compared to how much of the blue you can see here. Now the blue is less. That's not what happens in reality. We don't see less of an object while the bottom of an object rises and covers it. That's not what happens. And if that did happen, then obviously we could see that some of an object would appear missing, because let's say, for example, this right here was a mounting, right? This mounting, okay, let's say we can see just the blue bit, and that's the blue bit of the mounting that we can see. That's the mounting that we see. Now let's say refraction happens and therefore rises the bottom of the mountain up. What you are saying is the red bit is the bottom of the mountain, it's rising up, and it's cutting off some of the blue bit, some of the top of the mountain. So therefore, it would appear compressed and squished and like some of the mounting was missing. But really, it's not, is it? If that's the case of what you're saying. Because really, it's just the bottom coming up and hiding some of the top of it. Like how the red is coming up here and hiding some of the blue. So is that why sometimes things look smaller, or like some things are missing from an object, like a mountain? And they say that things are missing from it because it actually appears smaller. Is that why? Because the bottom of the mountain is rising up and like the red bit here and cutting off some of the blue bit? Like what exactly is happening there? I'm not entirely sure. But it's a thought to think about. So the red bit is behind the curve, whatever you want to call it, behind the barrel, behind the tank. It's down below what would be the horizon. Now, it's the light has obviously bent up into the more dense medium, because obviously he's put the more dense medium higher than what that is. So the light's bent up into the more dense medium and then bent down in the less dense medium as it's gone out the more dense medium into the less dense medium and come to the camera. So the light actually bends down in a less dense medium. So what would be classed as the horizon on this tank here, that never lifted an inch. It never moved. Explain that. Not only that, but the light is basically hitting this object, coming off this object, and he's put a more dense medium around it. So the light is coming off the object, entering a more dense medium due to the medium that he's put around it, and then coming out of that more dense medium that he's put around it into a less dense medium, going through that less dense medium towards the camera and then hitting the camera sensor. So therefore it's actually going from a more dense medium to a less dense medium, and that's what's actually causing this change, because that's what we're seeing. We're seeing it come out of a more dense medium into a less dense medium, where it comes and hits the camera and then we see the image. So this is actually showing refraction going from more dense to less dense to the camera, and then basically that's the observation that we see. And that is light entering from a more dense medium to a less dense medium to where the camera is, in a less dense medium. So this basically proves what I say, and is the opposite of what the Globers claim. Now what you should have done, because apparently we don't see things until the light reaches our eyes, so the light comes to our eyes and then we see things. So what you should have done is put that more dense medium where the camera is, so around the camera, and then the light would have reflected off the object, gone through the air into the more dense medium, and then hit the camera, which was in the more dense medium. But you haven't done that. What you've done, which would be representative of the globe by the way, but what you've done is put the more dense medium around the object, so then the light's bounced off the object, gone into the more dense medium, which has then gone into the less dense medium, and then through the air, which is the less dense medium, to the camera, which then the camera picks it up. So this isn't even representative of what you claim refraction to be, because this is more dense going into a less dense medium, because the light has to come from that object to our eyes or to the camera. What I would say is when we are doing these long distance observations, it would be best if we have, you know, from the camera to the observation point, the thing that you're observing, if we had people in between, and then you could get the data from where you are and where the observation's taking place, where that, you know, the object that you're observing is, and things in between, so places in between. Get the pressure readings, get the density readings, get the temperature readings, get all the data that you can. This will help us to understand what's going on.